Now take a look on this problem. The question over here is to calculate the live load of the slab of the building using the ASCE 7. We know that this building is an office building with mainly offices. So if we look for ASCE 7, we check for office building over here. And if we check for most of them are office, and then the live load is 50. So I have this one. The correct answer of that is 50 PSF. Now let's calculate the dead load. For dead load over here, we need to use the formula in the formula reference. Now you can go back to Canvas and check reference and check for me the formula reference. Now I will move all the way to the bottom over here until I see dead load. You see dead load over here. Dead load will equal to the unit weight multiplied by the thickness. The unit weight of this building is concrete. So if you go all the way to the top, you can see that the unit weight of concrete is 150. However, if you have reinforced concrete, you can use 160. So let's try 160 in this case. Let's try 160. So we can just apply that formula with the value we know, B. So this one dead load will equal to the thickness multiplied by the unit weight. And we know the unit weight from the reference is 160 pound over feet cube. And then the thickness, we can check on the bottom over here. We see that the thickness is 10 inches. So if we plug in 10 inches over here, so we let 10 multiply by 160. Is that correct? Do we miss anything? The answer is that we have this one in feet. So this one must be in feet as well. This one cannot be in inches. So what you can do is that you need to convert this one to feet. So we have 10 divided by 12 feet. So now if you let 10 divided by 12 multiplied by 160, you're going to have the answer of this one is 133.3 pound over square feet. Why? Because we have feet over here. Eliminate with this one, so we have 2 on the bottom. So that's why this one is square feet. Now let's check question C. Question C is to calculate the combined load. So now we need to go back to the reference sheet. So for the combined load, we need to use the combined that maximize the value of the combined load. So we have 5. We have 5 formula over here you can use. And because we have dead load and live load, so this one doesn't have dead load, I will delete that. Doesn't have dead load, I will delete that. This one, that the dead load, sorry, this one doesn't have live load, I delete that. This one doesn't have live load, I delete that. And then the live load over here is just 1 multiplied by live load. This one 1 multiplied by live load. Why this one is 1 multiplied by 1.6 multiplied by live load. So this is the formula we need to use. Actually, I put it over here for you, common load formula, and I put the most common formula that you use in this course is this formula. So we can apply that. See, we have the combine we equal to 1.2 up D plus 1.6 up L plus 0.5 of LR or S is no or R is rain. And we know of this one just equal to 0. The one over here we already know from A that is 50. The one over here we know from B that is 133.3. So the total of this we equal to 1.2 multiplied by 133.3 plus 50 multiplied by 1.6. We have this one is 239.96. I will just round up to 240, and this one is pound over square feet. Now we need to calculate the load on all the beam over here. First of all, we need to list all of the beam over here. On the way that I will show you a way to name the beam in this problem is that we're gonna use the grid line over here. You see this one is the point over here is the intersection between A and 1. I will call this one point is A1. This point is the intersection between A and 2. I will call this one is A2. So the beam from A1 to A2, I will call this beam is A1, A2. Okay. So then you can just this one is question is D, right? For D, I will have beam A1, A2, and then from here to here I will have beam A2, A3. Similar like that, I'm gonna have B1, B2, B2, B3, and then C1, C2, C2, C3. So I'm done with all the horizontal beam over here. Now let's check the vertical beam. So vertical beam, I have this one from here to here is A1, and this one is B1. So A1, B1, and then I have B1, C1, and then I have A2, B2. That is one over here, similar to that. And I have B2, C2, A3, B3, C3, B3, C3. Alright, so now let's calculate the load for each of that. The load of the beam, we need to check the formula. So if if you check the formula sheet, you see that the load for beam, if the beam is a rectangle slab, the load will equal to U multiplied by tributary width, and U over here is the combined load. So we just let U multiply by tributary width. So then I just do a demo for one beam. Over here, this one will equal to U multiplied by tributary width, and U we calculate that one on C over here. That one is 240, and tributary width beam A1 A2. Let me highlight A1 A2 over here for you to see. A1 A2 is over here, right? So the load that the beam will receive will be a half of this slab. This area will be the area that we transfer the load to the beam. Maybe let me remove the highlight, might cause confusion. So half of this slab will transfer the load to this beam, and the length of this one is from here to here, that is 20 feet, and the width of this one is 25 divided by 2 is 12.5 feet. So this one will be 12.5 feet. And by the way, this one is pound over square feet. So we have feet and then feet over here. So that's work. So this one will equal to 240 multiplied by 12.5. I will have this one is 3,000, and feet over here will cancel with this one. I will have this one will be pound divided by feet, or sometimes you're gonna see that I write PLF, that is pound over linear feet. It just means the same thing.